Okay, go ahead. Sorry about that.
Okay. Hi. Today my presentation's topic is about the modern C++ testing with Catch2. So in our group, almost everyone needs to use C++ programming to write a project. And one of the most important steps is to test your program. So basically, you may need to write some test programs or some unit tests to do that. So in this case, Catch2 is a very helpful and powerful tool for us to write unit tests. So how to use Catch2? It's actually very straightforward and very easy. You just need to download the source code, the source header, catch.hbb file, and put it in your source directory. And in your source code, what you need to do is just include the header. And that's all. You don't need to install any other stuff or link any other directories. And in order to link your project to a target, normally you need to provide a main. So basically, there are two ways. One is use the default main in the cache itself, and the other one is provide the user-defined main. So the easiest way is to use the cache that's provided by the use a main that provided by the cache itself. So what you are going to need to do is just add the define cache configure main before the include header. Basically just these two lines. As long as you have these two lines in your source code, you can build the target. And of course, you can also write your own user-defined main. So in this case, at least an example. This example is just trying to append a new command line option at the end of the original default one. So basically, what you need to do is first change the first line from catch configure main to catch configure runner, and then you need to create a session object here. In this case, we're just trying to append a new option, say something like a height, at the end of the original interface. So these few lines, basically what it tries to do is just get the original command line interface first, and then use the bitwise OR operator to append a new option. This is a bind variable to this option, and this is a hint of this option. -G and -height are the command line options, and also a string to describe this option. And then you put the whole new command line interface back into the cache, the session, and then just apply command line arguments. So in this case, we can parse our own command line options. But if your program is very simple and straightforward, I think in most cases just use the default main it's good enough for us to write the unit tests. Here is the result. As you can see, that a new option appended at the end of this default interface. There are actually a lot of other options I didn't list them. And then how to write a test case is also very straightforward. Just the string test case followed by two parameters. One is the test case name, the other one is the tag. The test case name must be unique. This makes sense, right? Because for different test cases, the names must be unique. But the tags can be not unique. And this tag is actually optional. But in most cases, I would suggest to write the tag for each test case. Because in Catch, it's very powerful. We can control which specific test case to run just by specifying the tags. And we can also group different tests with the same tag. Like, for example, I have a file called utility. I have a bunch of functions. I want to give all of them the same tag like util. So I can give all the test cases in the util function, in the util file with the tag util. And then in the command line, I can just run the specific tag like util. Then only those test cases will be run. And also for one test case, we can have multiple tags. It's just like, for example, we have a vector. Vector belongs to a class. It also belongs to container. So we can give different tags to the same test case. Like in this example. In the first example, we have 4 test cases and name them as A, B, C, D, and all of them with the same widget. So in this case, if we, in the command line, we just run tag widget, it will only run these 4 test cases. And also for one test case, we can have multiple tags. Like in this example, it has 3 tags. Test cases can be selected for running or just listed by tag. So in the command line, we can just list the tags, or even by an expression that combines several tags. We can also write an expression which combines like one or two tags. We can use and or. And there are actually some special tags in Catch. So before that, be aware that all tag names beginning with the non-alphanumeric characters are reserved by Catch, so you can't write a tag in that way. Here I list some of the most commonly used tags. The first one is hide. So it's kind of like disable a test case. So in some cases, maybe due to some serious bug, some test case doesn't work. You may just want to temporarily hide this test case. If you use hide or just a dot, it will make the current test case to be skipped from the default list. So if you run the default command line option, it will not run this test case. The next one is throw. It will let the Catch know that this test is likely to throw an exception, even if it's successful. So this will cause the test to be excluded when you run the no throw option from command line. And may fail. So doesn't fail the test if any given assertion fails, but still reports it. So this can be very helpful when you sometimes you have a bug and it's very complicated, and you don't want to fix it by now. You can just tell the program that even any assertion in this test case fails. That's fine. We know it. We can still make the final test case as pass, but this will be reported in the log. And should fail. It's similar to may fail, but it will fail the test even if it's passed. This can be very helpful if you want to be notified of accidental or third-party fixes. And the last one is non-portable. So this will indicate that the behavior may vary between platforms or compilers. Section. So when you write a test case, it may be a little bit complicated, and you want to separate that into different chunks. So in this case, we can use section. One test case can have multiple sections or subsections. Like in this example, we have section SA and some subsections SBSC and some other sections here. And for each section, the test case is executed from the start. I'll show that in the next example. So basically, in this example, we're going to try to test a vector. The vectors can be sized and resized. So in the initial code, I just create an empty vector with size 5. So we do some assertion like require size equal 5, capacity greater than or equal to 5. And when we try to run the first section, what's going to happen is it's going to run this code for the first time. And when we try to run the second section, it's going to run the initial code again. It's kind of like refresh all the initial values. And also same for the third one. So in this case, if you have any common codes or common variables that need to be initialized, you can just write them outside of the section body. BDD style test cases. So apart from that, BDD is actually named behavior driven development test cases. So in this case, we can write test case more like a scenario. It can help you actually to better structure the test cases. And if you write it in this way, you just need to replace the test case with scenario. And for the section, you can replace that with given, when, then, and when, and then. So it's more like an event of writing something. Here's an example. Like for the same example I listed before, we test the vector can be sized and resized. So in this case, we use scenario. And when given a vector with some items, and then we do some assertion or initialize. And when the size is increased, we increase the size, and then the size and capacity change. So in this case, it's more structured and more readable for users. And here is a log output for the scenario. You can see that very clear what's happening in this test case. And the next part is assertion. So basically, in Catch, it provides require and check for assertions. This is how we test our expression or value if they equals to true or false or some exceptions. So the two red ones are the most commonly used ones. Require expression. So the first one requires the expression to be true. The second one requires the expression to be false. And require no throw. Require no exception is throwing. Require throws. Require an exception is throw. Require throw as. Require an exception of the specific type to throw. So in this case, you need to provide an extra parameter, the exception type. And the last one is require throw with. Require an expression is thrown that when converted to a string, it matches the string or the string matcher. So in this case, you provide the string or string matcher, and it tries to compare if the result exception contains that string. And another one is check. So in this table, all the information are exactly the same except the prefix changed from require to check. The difference between require and check is that for require assertions, it will abort the test case at the first failure. So in this case, if you have some, for example, if in your test case you have a lot of assertions, and you may think that if one of the assertion failed, I don't want to test the rest of them because it doesn't make any more sense. It's useless. Then you can use require. It will just abort at the first failure for the current test cases. But using check, it will continue the test case. For example, if you say that even one of the test case, even one of the assertion failed, it may still helpful if we can see the other results, the other assertions. In that case, you can use check here. Here's an example. So basically, I provide a function named one, just return a string one. And in the first test case, we are trying to use the require. Require 1 equals 2x. This is definitely wrong, so it's gonna fail. So in the first test case, the second assertion, require 1 equals 1, will not be tested. So in this case, we have one assertion and one failure. Same for the second one. But for the check, the first one, though it's gonna fail, but we're still gonna continue the test. So the second one is also gonna be tested. So in this case, we have two assertions and one failure. And same for the last one. So the total result is going to show like we have assertion 6, 2 pass, 4 failure. And the next part is the log message. So it's kind of like provide an extra way for us to see some logs or output information, so we can better debug or track our code. It's kind of like a standard cout. Basically, in Catch, it has 5 options. We can use info. Info means that the message is reported when an assertion fails. So it only reported when in your test case you write the info. It only reports the error message when that test case fails, and the message is gonna remove from the buffer at the end of their scope. The second one is warning. The message will always be reported, but it will not fail the test. So no matter if the running result is successful or not, it's always gonna show this warning message. And the next one is fail. Fail is gonna make the message be reported and the test case fail. Fail check is similar to fail, but it will not abort the test. Capture. This can help you to quickly capture a variable value. So these macros allow heterogeneous sequence of values to be streaming using the insertion operator in the same way that standard output supported. So like in this example, we can use this info to output as much information as we want, just by simply using this output operator to combine them. Here's an example. In this case, we use info. So in this test case, first we use info to print some message like test case start, and then we check the I value. If I value equals to 1, so first I is equal to 0, so it's gonna fail the first test case. So it will print the message because it fails. Test case start, the number is 0. This test case failed, as shown in this example. And next, when I equals to 1, it's gonna succeed, pass. So it won't show that message. And then check false. This is gonna fail. So it's gonna show the message test case start. And at the bottom, you can see that Catch will tell you how many test cases it has run and how many assertions it has run, like how many passed, how many failed. It's very clear. And the last part is command line option. So here I list a lot of the ones that are most helpful and commonly used. The first one is help. You can use dash question mark or dash H for help. The next is dash L. Using this command, it will help you to list all the matching test cases. And dash T will list all the tags that you have in your test case, in your test program. And dash S is going to show all the output, all the detail of each test case. So if you don't use dash S and run the default command line, it's going to only show the detail of all the failure test cases. But for the one that passed, it won't show any information. If you want to know the detailed information, you can just add a dash S. And the dash O means output file name. It's gonna output the result log into a file. Dash A means abort the test at the first failure. Dash X means abort after X failures. And dash D means show the test case durations. It's gonna show the time, basically. So next, I'm going to show some examples. basically here I have I provide some examples like in the BDD scenario, require check assertion, section, login, and the main function. So in each of them, I wrote some test cases. And you can see that the only thing I did is just include the cache.app file in this directory. And if you see the main function, it's going to be like this, exactly as the example I showed before. And let's see some other examples, like require check assertion. In this one, I did some test cases in this file. And for each test case, I give it one or more tags. So let's see if we just run the target, what's going to happen. It's going to show that all the first at the bottom is going to show how many test cases it run, how many passed, how many failed, and how many assertions. And in the log information, it's going to only show the ones that failed or the ones that you have a warning message. Like this. And this one is just a test case name. And it's going to show that warning with this question. Or fail here, like this one. And if we use -L, it's going to list all the test cases with their tag information. So in this case, actually we can just run specific tests by using the test case name. Like for example, I just want to run the for one. This is gonna only run a specific test case, so it's very convenient. We don't need to always run all the test cases. And another option is -T. It's gonna list all the tags that we have now. Like in this case, we have 8 tags, and for each tag, it's gonna tell you how many test cases it has. Like if we only want to run the section 1, we can just write a section, append the section at the bottom, at the end. Yeah, it shows that 6 assertions and 1 test case. And what's more, maybe I want to like test both section and scenario with this comma actually means or option. If you don't have any comma between them, it's gonna mean and. That means I want to run the test case with tag section and the scenario. But in this case, we use a comma here. It means I want to run the test case with tag section or scenario. Yeah, so it's going to run the result. What's more? But for this one, since as it shows that it didn't show any detailed information of what the test case is, what it run, and what the log information. So if you want to see that, you can just write, you can just append the -S. So in this case, it's gonna show all the different detailed information, like what the test case name, what the section name, or scenario name, and what assertion it did. Let's show it. What's more, maybe -A. -A is gonna abort the test at the first failure. Yeah, so if you have you want to check if there is any failure in your program, just using this will be very fast. -X is this will abort the test and after 3 test cases, after 3 failures. So yeah, sure. What's more, maybe the -D option. It's going to show the time when you provide an extra parameter. As shown here, it's going to show the running time for each test case. In this case, I think the test case is very small and simple, so time is almost 0. But if your program is very large and slow, it must have some values. I think that's all I want to show. Here's the reference for this Catch2. If you are interested, you can just download it from there. It has its own documentation and some examples are provided. Any questions?
How large is the size of the Catch2 HPP?
I haven't checked. Let me check. About 434 KB.
Okay, it's not much. Do you use the Catch2 for the SPL and SPL library testing cases?
Not in those code, but I'm using it for. I wasn't aware of it when maybe it didn't even exist. I don't know.
Yeah, because it looks quite similar. Yeah, when I'm doing the test for the SPL test.
I'm not actually using it for that, but I am using it for the programming assignments for the new course that I'm working on.
Okay.
It's really convenient.
Yeah.
That's why I said. Jay was looking for some way to do some unit testing for some of his code, so I suggested he might want to try it. And I think it's safe to say it is like really easy to use.
Yeah, right. It's very easy to use.
I have a general question here.
Sure.
When you are writing your test cases, do you write them in the body of your code or in a separate file?
This is a good question. Like in our case, if our program is very small and simple, so we can just write it in the body of that test case. But in the industry, normally they won't write any hard code in the source code. What they do is that they put all the hard code, like the data, into a separate file. And then maybe in that file, each value has a key. So what they're going to do is write some functions to be able to search that file with the key and the file name. And in that case, they won't write any like source data in the test case. They just use a key to search if this matches this.
Okay.
Yeah.
And because the question I have is that, like, let's say you have a source file, your actual code, your real code that you want to test it, right? It contains like 10 functions.
Right.
And function 2 depends on function 1, like they are dependent on each other. Like go till function 10, and you only want to test function 10. Okay, so you write a test code to test the function 10. So basically, because function 10 depends on function 9 depends on function n, and goes to function 1. So your test case should run the whole program from the beginning, right?
Right.
Until it gets to function 10, and runs the test case for function 10. Is that true? Does it work like this?
I'm not sure, but I think it's the case that the program runs from the top to the bottom for each test case. So what you're gonna do is like maybe just in the first test case you write for the function 1, and for the next one you run for the write a test case for the function 2, until at the bottom you write that for the function 10.
Okay.
Yeah.
So basically, if your program, let's say the execution time for your program is 10 minutes.
Mm-hmm.
So each time you run your test cases, it should take almost 10 minutes, right? Because it runs the whole program from the beginning to the end, right? For each test case.
Right.
Right? Is there any? Have you noticed any shortcut to make it faster, something like that?
Actually, in Catch, it provides another very powerful tool called benchmark. I didn't introduce that here, but basically, what it's trying to do is that it's gonna trying to cache all your running results every time you run the whole program. So, for example, if you run it once, it's gonna cache some result in the backend. I think, no backend, just cache some result. But if you say you run it 10 or 12 or 20 times, every time the time is gonna be faster because it caches some values in it.
Okay.
I don't know how it's the inside, the internal how it's right, but I know it provides such a function. Yeah. So I think that may be helpful for us.
Okay. So it doesn't take the same amount of time each time.
Right.
What you're saying is that it gets faster and faster after running different test cases.
Yeah, if you run the same program, of course, like if you didn't build it before.
Okay.
Maybe just to interject one clarifying point.
Mm-hmm.
Like when you're essentially those test cases that you write, they're like individual names. Kind of, that's maybe one way you could think of them. Like each test case is a separate program, and you provide as many of these test programs as you want. It just provides a convenient framework for writing. Essentially, it's kind of like it's not actually run as a separate program, but it's kind of like that. So you wouldn't put your main for your whole program inside a test case. Like you wouldn't run the whole program. It's more for what we call unit testing, where you have different components of your program, and before you put them all together and watch nothing work because the individual parts are broken, you first test the individual parts. This is called unit testing, to make sure the individual components. Maybe you have a bunch of different classes: class X, class Y, class Z. So you write a bunch of test cases for class X, a bunch of test cases for class Y, class C. Then you get all the bugs worked out, because there probably will be some. And then once that's working, then you put everything together, and then you have some hope maybe it will work. It probably will still have some bugs from combining stuff together, but at least you know the bugs are from combining. It's not because the individual parts themselves are broken.
Yeah.
So this Catch is really more designed for unit testing. So I'm not sure if that was quite clear. It seemed like maybe when you're talking about running the program, you're not running.
Right.
You're not actually running a full application inside the test cases. What you're doing is you're writing small little programs of your own, effectively saying, I want to test this part of class X, this part of class X, this part of class Y. And it just gives you a framework that's convenient for writing the test cases, and you can select between them, for example, because you might not always want to run all of them, because there could easily be hundreds, or in a big project there could be thousands or tens of thousands, so you can choose which ones you want to run.
Yeah, each test case should be independent from the other one. I think that's the main reason for unit tests.
And I think probably for most practical uses, probably your test cases would be separate source files, because you would, if you have some class you want to test, you would write a separate file. You would include the header file for that class, and then you include the header file for Catch, and then you write a bunch of your test cases. And then when you compile that file, if you did what Jay was showing for including name, if you do that special magic, then it causes that header file to insert a main function, so you don't have to write it yourself. And then the main function understands all the command line options.
It contains all the command line options.
One thing that really sucks though, because the header file is half a megabyte long, your compiles really, really slow down when you're compiling code with Catch. A lot. I have not too large files that are taking maybe 15 seconds, 20 seconds to compile, because it's including a massive pile of template code from this header file. But it's okay. When you run tests, normally you just start it running and you go for coffee break or you go to sleep. It doesn't matter if it's slow.